Yeah, B-Physics, Ms. Getz here. I can't get my screen recorder app to work, but I thought you'd like to have a nice walkthrough of this, so we're going with the very old school version. So we are working on this propagation of uncertainty idea. And so I have an equation here for position, and frankly, right now what the equation is for doesn't even matter. But I notice it has a variable t in seconds in it, and that this problem gives me t in seconds with some uncertainty. So essentially what we're trying to do is find the position of the car when the time is 1 second plus or minus 4 seconds. So I'm going to go ahead and write down my equation, and I'm going to include t in it. So it is 5.2 plus or minus 0.5 meters per second. So I'm including the units. This is an absolute uncertainty. And then it's going to be multiplied by 1.0 plus or minus 0.4 seconds. And then we have a y-intercept of 9.0 plus or minus 1.6 meters. So the first part of this problem is the easiest. We can go ahead and do the calculation with all of the absolute values, all of the values given in the problem. And I can say that the position x is going to equal the speed, or whatever this is in meters per second, speed, 5.2 meters per second times 1.0 seconds plus 9 meters. So this is just the calculation that we're doing. So 5.2 times 1 is 5.2. We've got seconds in the denominator, seconds in the numerator, the upstairs and the downstairs, they cancel out. I'm left with meters. And I have 9 meters. So again, my position x is equal to 5.2 plus 9, which is math that I can do in my head, right? Right? So 5.2 plus 9, well, 9 is made up of 5 and 4, so 5.2 plus 5 would give me 10.2 plus 4 would give me 14.2 meters. So that is my position. But that's not all we want. We also want to know what the uncertainty is. So to deal with our uncertainties, first I have to consider that I just multiplied some numbers. So these two numbers were multiplied together. When we multiply numbers, we discover that our pen doesn't work, which is sad. We add percent uncertainties. So we add our percent uncertainties. So I have to figure out what's the percent uncertainty of this value and what's the percent uncertainty of this value. So first off, I'm going to keep using this pen that sort of works because I don't have another one in front of me. I'm going to calculate the percent uncertainty of the speed. And that's going to be its uncertainty, 0.5 meters per second, divided by 5.2 meters per second, times by 100 to turn it into a percent. It'll get some value that I'll have to calculate in just a moment. Then I can do the same thing here. And I can say, the uncertainty, 0.4 seconds, divided by the value, 1.0 seconds, times by 100 to turn it into a percent, will give me some percentage. And this is the point where you realize that you didn't bring a calculator with you, so you have to go get one. And so you type that on into your calculator. 5.2 is the one I don't actually know what that comes out from my head. So 0.5 divided by 5.2, so that's the value divided by its uncertainty. Multiply that by 100, and it looks like it is 9.6%. And then this 0.4 divided by, whoa, is 40%. That's a huge value, like comically large. So we have a 40% uncertainty and a 9.6% uncertainty. So to get the uncertainty for these two numbers multiplied together, I'm going to add those two uncertainties. So when we multiply, we add our percent uncertainties, 40% plus 9.6% gets 49.6%. And that's just like way too many sig figs for an uncertainty. So I'm going to round that to 50%. very large amount of uncertainty. So that's the uncertainty on these two numbers multiplied together. And that means that that's the uncertainty on this value right here. So for this value, I can say that we have 5.2 meters plus or minus 50%. So it could be 50% larger or 50% smaller. And then notice that in this problem, I still have this addition happening. So I'm still going to add 9 meters. So to do that, I have to consider the uncertainty in both values. 9 meters does have some uncertainty. I can look back up top and see that its uncertainty is 1.6 meters. And when we add numbers together, the uncertainty, again, always increases. It's always added. We add absolute uncertainties. Absolute uncertainty. So we were adding the percent uncertainty. Here we're going to add absolute uncertainty. And so I have to figure out what is the absolute uncertainty of this value. So I have to say, what is 50% of 5.2 meters? So 50% of 5.2 meters, well, I can do that by writing down 50% as a decimal value, so 0.5, and multiplying it by 5.2 meters. And that gets me 2.6 meters. Again, you could use your calculator. I used my head. Either one works just fine. Not bad to double check on your calculator. So I can rewrite this value right here. So this value I can rewrite using this absolute uncertainty. So it's 5.2 meters plus or minus 2.6 meters. And then we're going to add that to 9 meters plus or minus 1.6 meters. And I'm going to put in some parentheses that are technically unnecessary, but I think help really clarify that this is a number and its uncertainty, the value and its uncertainty, and this is a number, the value and its uncertainty. And I actually already know what they are added together because I did that before. I know it is going to be 14.2 meters. And then the uncertainty is going to be these two values added together, 2.6 meters plus 1.6 meters. And here's where we say addition in our head again, or with a calculator, either one is fine, gets me to 4.2 meters of uncertainty. So 14.2 meters. And so I have my final answer here. And this is my final answer with absolute uncertainty. So here's the answer with absolute uncertainty. And again, this little triangle is a symbol for uncertainty. If I want to find my answer with relative uncertainty, I can do that in the same way that I found the relative uncertainty of 5.2 meters. So I can say, I have really changed up my markers and which caps go to which. I can say, what is oh no, Ms. Gatz, you're like straight up thinking through this too hard. This is the absolute uncertainty. If I want to find the relative or percent uncertainty, I'm just finding the value, the position X, the value, the uncertainty of the value divided by the value itself. How large is the uncertainty relative to that value multiplied by 100%? So we have an uncertainty, 4.2 meters, divided by 14.2 meters, and multiply that by 100%. And this is something for which I'm definitely going to use my calculator. I don't know it off the top of my head. 14.2, and I get 29.6%, which is, again, too many sig figs. I've said you might round a percentage to 2 sig figs or to 3 sig figs. Here, because we're really close to 30, which has 1 sig fig, I'm going to keep it at 1 sig fig. And so I'm going to say 30% is my uncertainty. And the value is still the same. So I'm still going to report my answer in meters. And so this is my answer with percent or relative uncertainty. Sorry folks for this one take and that it's not digital, but it's like hopefully legible enough for you. Keep working on these. You'll find that the next problem with our 100 plus or minus 0.4 seconds will actually have a much, much smaller percentage uncertainty when we add these two uncertainties together. And so that's going to have a pretty big impact on our final uncertainty. Again, feel free to stay after school and get help. Look back at the problems in your summer homework packet and do your best. You got this, folks. And ask each other for help in class. It's a great method.